Okey-dokey. This is a real short unit on circle and, excuse me, it's actually on conics. Conics is just a fancy way of talking about graphs and ellipses and hyperbolas and all that kind of stuff. I didn't even know that until a couple of years ago. Someone asked me when I did my unit on conics, and I was like, I don't know, what the heck's a conic? So anyway, it's a real short little unit, so probably you have a test on it next week sometime. Get it going here. Today's just a circle in the ellipse. All right, we'll start with circle first. Formula that we're going to look at for a circle, it's actually x minus h squared plus y minus k squared is equal to r squared. The y and the x will stay y and x, but that h, k, and r will actually be different values. You know enough from your old geometry days to know that your r is going to be the radius if we're dealing with a circle. The h and the k is going to, well, it's going to be a pretty important point. It'll be the center of the circle, okay, which is a point. You're correct on that. Now, what I need you to notice about that h and k, up there in the formula it says x minus h, but I put a positive h down there where I put center. Up in the formula it says y minus k, but I put a positive k down there where I put center. It's always the opposite sign on the h and the k on the center. Okay? That's actually derived from the distance formula, if you want to get into it and figure out, because you know radius is the distance from the center to the edge, so you could use the distance formula to derive that, but we're not going to get into it. We're just going to use it a little bit. Okay, so starting us off with a baby one here. Everybody got the formula? You ready? All right, I got a center at 0, 0, and a radius of 4. My directions say to write the equation and graph. Draw the graph. All right, so to write the equation, first off, we know everything we need to plug in. We know an h. What's our h? 0. We know a k. 0. And we already got the r written over there. So if I start plugging that in, that formula that you wrote, I'm going to have x minus h squared plus y minus k. Oh, I'll put a k, dummy. I can't multitask. Y minus k squared is equal to r squared. So if my r is 4, what would 4 squared be? 16. Now that's a correct equation, but you won't see that as a choice because we know what x minus 0 and y minus 0 is. How can I rewrite x minus 0 and y minus 0?
X squared plus y squared.
Good, very good. So this is the same as x squared because x minus 0 is x plus y squared equals 16. So there's my nut. I put two plus signs in there. That was stupid. I erased on mine, but not yours. Let's see if I can scribble the one out that I erased. There we go. So there's your equation. There's your part 1. Now the graph of this is easy. Just draw a little makeshift graph over here. I know its center is at the origin, 0, 0. All you're going to do when you graph these circles is start wherever the center is, and they're not always going to be at the origin. That would be too easy if they were. But then from the center, count your radius in all 4 directions. Count it to the right of the center, count it up of the center, count it to the left of the center, and count it down. So here, if I go a radius of 4, 1, 2, 3, 4, I got to go through that point, back to the origin, up 4. I'm just doing a 4-unit radius all the way around. And then you draw your circle around those 4 outer points. I don't know if I can do fancy shapes on here or not. I'm going to try. Oh, it doesn't have a circle. It only has the ellipse on this part of it. Oh, we'll just do my ugly circle. First period had to see it. Y'all should too. Beautiful.
What is that squiggly stuff?
Right here.
Right beside the mouse.
Yeah, I was right. I put 2 plus signs on accident, so I scribbled one out. Sorry. My teacher's writing gibberish. That's what it looks like, Mason. Zoned in. Alright, so that's when we got the center at the origin. Easy schmeezy on that. Let's look at what it looks like when we move it a little bit. Ready? Alright, I got the center is at 3, -2, and the radius, sticking with 4, is 4. Directions are the same. Write the equation number 1, draw the graph number 2. Alright, so what is my h? 3. So that will be x minus 3. Remember, it has a opposite sign. And it's always squared in that parentheses. Plus, what's my k? Go ahead and say it like it is.
-2.
-2. So when I subtract -2, that's why it turns it to the opposite and makes it a positive. Okay, so everybody good on that? And then r squared, 4 squared. That's it. You've written your equation. So the only thing that's going to be different now when we go to our graph, instead of counting from the origin, my center is at 3, -2. So I got to count 4 in every direction from that center. So from down there in quadrant 4, I got to go up 4. 1, 2, 3, 4. Right 4. 1, 2, 3, 4. Left 4. 1, 2, 3, 4. And down 4. 1, 2, 3, 4. So you draw your circle around those. Easy schmeezy. Okay, I'm gonna let you try one of those before we look at I guess the hardest part of a circle, and then we'll move on to ellipse. Got what we need on that one? No problemo, sir. Got my. Alright. Let's see what we got here. The center is at 2, -1, and a radius is 3. Okay? Won't take you but a minute to do that. I want you to do the same 2 things. Write the equation for it, and then graph it, and then we'll look at the harder part of this, and then we'll move on to ellipses. Hello? Hello? They're just... Alright, so let's write our equation. You got x, did you write plus or minus? Minus 2, don't forget to square it, plus y, plus or minus?
Plus 4.
Plus, very good, and don't forget to square it. R squared, 3 squared? 9. There you go. You wrote the equation of a circle. Hot dog. Okay, now let's graph it. First period got confused every time when I went to graph it. They didn't realize that you needed to go back to up top where I told you what the center was. So I went right 2 and down 1, which is what I should do, but they thought I should go left 2 and up 1 because of the way I wrote it in the equation. The equation just writes it backwards, so don't go the way the equation says. Go opposite of what the equation says. Okay, so there's your center. Now I just got to count 3 from that in every direction. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And you get your beautiful circle. Alright. Did you do alright? Okay, this next one, like I said, is going to be the more difficult of the circle problems, and you'll see why when I get it written here. It says x squared plus y squared plus 2x plus 6y is equal to 15. The directions say find the center and the radius. We haven't seen anything yet that looks like that. We've had stuff that had an x squared in it. We've had stuff that had a y squared in it. But now all of a sudden we got extra x's and y's up there. So we need this thing to end up so that it says x plus or minus something squared plus y plus or minus something squared, right? That's what we need it to look like so we can know the center. And it doesn't look like that. Okay, those little blank parentheses that I set up for you down there, those are perfect square trinomials. So what we're going to do, and I'll do it over here on the dry erase board so we can keep it looking. I'm going to take just the x's that I have there. The x squared and the 2x. I got to figure out x squared plus 2x plus what will make me one of these. Okay, and we did this in Algebra 2 and earlier in this year when we did completing the square. So you might want to make you a note that when you see something that looks ugly like that, you're doing completing the square. You start by taking your b, halving it, and then squaring it. Okay, so 2 divided by 2 is 1. 1 squared is 1. So if this said x squared plus 2x plus 1, I could rewrite this as square root of x squared is x, square root of 1 is 1. It'd be the same as that. Okay? But I just can't add a 1 to something magically. If I add a 1 here, what do I got to do to that 15 over there? Add a 1 also there. So we got that first parentheses there. I'm going to have that x plus 1 squared. And over here, so far, I got 15 plus 1. Now we got to figure out about the y's. Okay, so my y's, I got a y squared and a 6y. So I got to figure out what I'm going to add there that's going to make me have a perfect square. So take your b, half it, half of 6 is 3, square it, 3 squared is 9. What's the square root of 9? 3. Okay, but I can't just magically add a 9, so I got to go add a 9 on both sides of the equal sign. So that parentheses with my y's will say y plus 3 squared. And then I got 15 plus 1 plus 9. Okay, so you now already know the center. What's the center of this circle?
-1, -3. Is that right?
That is right. Yes, Mason, go ahead, Chase.
Why did you automatically put plus?
This sign, and that's a good question, this sign will always be a positive because anytime you square it, it's a positive. And so your sign that goes here will be whatever that sign is. So all of these were positives. So if this had been a minus 2x or a minus 6y, it would have had a minus there.
Okay.
Good question.
That's
Good, Mason. Okay, so Mason said my center was -1, -3, and that's correct. Let me get a new color so we don't lose that. Oops. -1, -3 up there at the top in green. There's your center. Okay, I got a little bit of work to do to find my radius. 15 plus 10, right? So that's 25 that's equal to. So if that's equal to 25, that's r squared. What's my r? 5. So we got a radius of 5 and a center at -1, -3. Because 15 plus 1 plus 9 was 25. And then we took the square root of 25 and that was 5. Not a ton of problems like that, but you do need to be reminded of stuff like that every now and then. Alright, I got a couple of ellipse problems, but we got to write the ellipse equation. I just assumed too much, and I started talking about ellipses, assuming first period knew what they looked like. And finally, a poor little girl raised her hand and said, I don't have any idea what an ellipse is. My best explanation is it's an oval. Kind of an egg shape, an oval shape. You know, sometimes my circles look like ellipses. But what you're going to notice special about an ellipse, other than the fractions, because anything could be over 1 and be a fraction, but it's going to be equal to 1. Notice this one doesn't say equal to r or anything, it says equal 1. So it'll be a 1 over there every time. Now out of this, the a, 0, and negative a, 0 are going to be your x-intercepts. And then 0b and 0, negative b are going to be your y-intercepts. Okay, so that's the notes we need to go with that, and we'll work a problem or two. Alright, we ready? Okay, I got x squared over 4 plus y squared over 25, so squared up there, is equal to 1. The directions just say to graph. Alright, so we're going to graph this dude here. Now, an ellipse doesn't technically have what can be defined as a center, because your math definition for center says that it has to be equidistant. You know, a radius is the same all the way around a circle. But when it's an ellipse, it's an egg or an oval shape, it could be more distance to the top than it is to the side, right? It's not the same. But there's still a point that looks like it's in the middle. Even if I can't technically say it's the center, there is a point that looks like it's in the middle. And I know that this one is going to be at 0, 0. Okay, so I know the middle of that ellipse is going to be at 0, 0. And here's how you know that. There is nothing extra going on with the x and the y. It's just x squared. It doesn't say x plus 2 or anything. It's just y squared. It doesn't say y minus 7 or anything. So just a plain old x squared and a y squared. The middle is going to be at the origin. So all I got to do now is put these intercepts. What's my x-intercept going to be?
2.
Very good. 2, 0, and negative 2, 0. Bam, bam. Good, Chase. Bam, bam. What about my y-intercept? 5. He's just taking the square roots, right? So 0, 5. And 0, negative 5. And there you've got an oval, an ellipse. So see what I mean? This point is in the middle of it, but it's not technically the center because that would be a different distance, right? Now, we found those intercepts real easy, but what if the middle is scooted over here? We would have to make adjustments on these intercepts, wouldn't we? So that's what we'll look at next. How about x plus 4 squared over 16 plus y minus 1 squared over 36 is equal to 1. Alright, where do you think the middle of this ellipse is?
-4.
Okay, opposite signs just like on the circle. So Kaylee be right, it'd be at -4, 1. Just like we use the opposite signs on the circle, we're going to do the same things here. So I would go left 4 and up 1. And that's where the middle of that thing is going to be. Okay, so now when we square root the denominators, that 16 would be a 4 and a -4. You just don't start from the origin. You start from that middle. So from that middle point there, I'm going to go horizontally 4, 1, 2, 3, 4, both ways. 1, 2, 3, 4. Okay, then my y, the 36, the square root of that, 6. So from my middle point, I'm going to go up 6 and down 6. So we still had to use those square roots. We just didn't start from the origin. We started from our middle point. Not very difficult. Not very hard at all. Okay, I'm going to, any questions on that? And I'm going to give you one to answer in your exit question. And it's an easy one. That's what we need there. Alright, it says x plus 3 squared plus y plus 2 squared is equal to 25. I just want to know, this is a circle, what is the center of that circle? Let me push the button. It isn't there yet. Let me push the button. Got open classroom. Alright, I had to refresh, but it just showed up in mine finally. Let's get that answered, and then hyperbolas will be the graphs that we look at tomorrow. That'll be a wrap. Mason, did you get a study guide?